Today, as it's written in the course, we're going to have a lecture from our colleague. He is a postdoc in our chair. His master's is in, he's an engineer, systems engineer, and he did a PhD in architecture. So today he will talk about urban data streams and machine learning. So his name is Vahid Moosavi, and we will leave you with him.
Okay, thank you very much. So, okay, maybe I should come closer to see my screen. Is okay? Okay. So, thanks a lot for inviting me. Yes, my name is Vahid. I'm a postdoc at the chair, working with Guru and Carla together, and I'm in principle interested in data-driven modeling for engineering applications and also spatial and urban applications. So by background, I don't have a background in architecture. My background is originally in computer science and systems engineering, but then I did my PhD here and also at Future Cities Lab in Singapore in this general topic of machine learning and big data for cities. So if I refer to my background, which is a systems engineering, that's the starting point why we are interested in principle in data-driven modeling and machine learning. If you think about classical disciplines or the way research has been organized during the last 400 years, we have these kind of silos of topics, and then correspondingly we have experts in these topics. For example, you have economists, you have people who are thinking about urban energy or building energy, you have people think about infrastructure and spatial development, and then transportation expert, and so on and so on. But then the fact is that in complex cities of today, we have in principle the so-called complexity, which means that you have questions, we have problems with many different aspects. So the current problem is that then because of that, over the time you see these fields like multidisciplinary research or this kind of interdisciplinary research that are emerging, and that's the reason because none of these domain expertise is enough to cover these problems. Because if you think about a problem like air pollution, why this happens? You have from one side engineers, they say, okay, we would like to model this as a kind of fluids, like you have the physics-based equations to model how particles moves in the space. And then from the other side, you know that there are lots of other issues like land use will affect, and I don't know, for example, road network structure is important, greenery is important, a lot of factors. So if you think about it classically from engineering point of view or simulation point of view, it's very idealized and simplified, so you can't model that. And then if you want to integrate other aspects, you can't do it, because imagine how you want to integrate patterns of movement of people into the way that cars are being used, and also how people will move in the cities, and then which kind of greenery we will have. And think about it in terms of classical simulation, this is not working. So it's always a kind of problem that is open. So you think about energy, city level energy planning. Who is responsible for that? Nobody knows, because there's a lot of different topics. And then you have from one side sustainability comes, and then you have people's behavior, you have economy, and a lot of this issue. So that's the current setup. And then the original idea of systems engineering was that can we look at them orthogonally? So don't focus like that. If there's a columns, don't look at these columns, try to see them from the row. And now the whole hypothesis is that with this data-driven modeling, we are having an inversion. And if you now think about these kind of generic skills that I believe you're learning in this course, you're learning these techniques which are very generic. In principle, computer science is not belonging to any discipline. And then you can think about machine learning, and then you have these are blocks that I believe are important: statistics, probability, optimization, linear algebra, and then nowadays called data science skills. And then you need to really just learn how to work with these few types of data, either text, image, time series, networks, and then structured data. So if you have this kind of literacy or skills, then you can think about all of them in a different way. In order to, because if you learn, I don't know if your background is engineering or architecture, for example, if you go and become a civil engineer, you learn for 5 years a certain skill to solve certain questions. And now with this situation I described for you is that you don't know what is the question. So then the question is that should we learn this classical approach or not? The approach of data-driven modeling is that you focus on these local temporal situations, and we call them data-driven projects. So these are the questions. You need to find good questions, and then if you're skilled or, let's say, literate in these kind of generic techniques, you can put them together, and in a way you can glue these different things together. For example, if you want to measure air pollution, if you know how to use it, you can go through Street View, drive through streets, and take data from Google Map, for example, Google Street View, and then do some measurements. And then this machine learning has no clue about representation of air pollution. You can just learn that if the picture of the streets are like that, what is the expected air pollution at the street level? Or if the streets are like that, or the houses are like that, or the cars are like this, what would be the expected price of this region? So you see, it's not anymore about representation, so it's about what you are asking. And if you know how to play with this data, you are completely nomadic, I would say, in this disciplinary field, because you can go everywhere and you feel relaxed. So that's the positive story of my background. Oh, also there are some sort of negative part. So then, in principle, I should also add that if you think about these columns and rows, these are about techniques, and these are about, the other side, in principle, is about applications. And I also have a course. You're welcome to join this semester. I'm off, but from next semester, I'm just teaching these techniques. So today I'm not talking about the techniques at all, but it's important to learn all of them. And then if you follow the hype, it's really problematic, because nowadays everybody follows what is happening in DeepMind and AlphaGo, or I don't know, the state of the art in deep learning. But if you want to really learn it from the basics, it takes time. So the whole idea of this course is how to learn it as a new kind of language, but not in a way that computer science students are learning, because for that you need 4 years, but I assume that you are already an expert in your field, and if you want to just learn it as a second language, for example, if you're a native speaker in one language, how can I learn a new language? That's the whole idea of this course. You can go there, and then also our video is online on YouTube, and then the codes and lectures and all the one-by-ones are here, so you can go, for example, if you want. These are the topics. You can look at them. So today I'm just going to talk about 4 applications. So, and then that's very important, crucial point, not to think about it as a new tool or as a new expertise. Because if you are architect, classical architects, always they say, for example, we are master designers, we are master architect, and we need bunch of IT guys for rendering and, let's say, any types of simulations. But what I strongly believe is that you should really think about it not as an expertise, but as a literacy. And machine learning and data could be a new kind of language. And if you know how to think about it, you will think about everything differently. And it's not just that you know what you want to achieve and now you go to a computer expert to say, okay, can you solve this problem? No, if you really know this, you will ask different questions. And this is what, for example, our group, we strongly believe. And this is different than the classical way. So in terms of applications, because of my different backgrounds, I've been working on this machine learning, or let's say data-driven cases on different fields. So namely in urban spatial application, a few of them. But then, for example, some of them are more kind of technicals. We are trying to develop new tools, for example. For example, there's a problem of, for example, urban flood risk estimation. But then if you take the so-called CFD models, they're really slow at the larger scale. So there, the data is coming from the simulator, and this is called emulator, because there is no data, but you get the data of these slow simulators, and then you train another model to learn the behavior of the simulator, and then in principle this can be almost real time. So then that's a current problem, which is called computational complexity. And if you come with the background of hydrology, most likely you don't like this approach, because they say, no, I like to really represent molecules of water, how they're flowing and so on. But the fact is that you can't simulate. You can't be faster than reality. So then here we want to be faster of this simulator by being non-representational. That's important. It's just learning what is your question. You learn a certain landscape, if it's like that, and if it's going to rain like that, what would be the risk of flood? Not to just simulate what would be the movement of every particles of water or molecules. So then you can think about it in different types of flows. It could be energy, it could be air quality, it could be water, and then these are all computationally following the same types of paradigms. And now with this machine learning, I have been trying to work with different experts to see if we can improve this situation. So also there are some applications, I will show you some of them, which is a kind of startup idea I'm pushing for real estate markets. Also some application in the field of systemic risk and world economic networks. And there are also some other applications that, for example, the first one is structural design. This is a very, for me now, an active topic. I'm collaborating with 2 chairs here. We are working on integration of machine learning into problems like form finding and then design space exploration and so on. So, but if I believe you have, based on the previous sessions you had, you are familiar with this term, but classically I like to start with this, why we have big data in principle these days. And if you quickly think about that, what happens in 1940s, 1950s, this is the beginning of numerical computers, or like what we have as computers. And then you can correspond different types of computational modeling to each of them. For example, in computation is the time of when you have mainframes. And then when you go to a certain level of maturity, you reach to another level, which is about networks of computation. So then this is the time PC comes, internet comes, and so on. And then also conceptually, you can think about concepts like agent-based, ecological thinking, sustainability. They're all started when you think about networks of interacting elements. And before that, everything was like very centralized and so on. So I don't want to go to that topic because this could be like also another topic of history of computational urban modeling in architecture. But nevertheless, with this advancement in computational networks, and also nowadays it's called ubiquitous computing, pervasive computing, and social media, now it's not anymore about this, even the network, it's about the activities you are doing. So almost all of us, we have a lot of sensors, a lot of receivers, and so on, and we are emitting a lot of data. And this is now, you can call big data, you can call it data streams, and the main difference here is that these are the data which are not, you are not able anymore to model. Because in the previous paradigms, you always had a certain context, and you said, okay, I want to have these types of data, and then you go do your experimental design, and then you do the test, and then you have your collected data. So you know what you're going to get as a data. With big data and data streams, everything is unstructured. They are not designed for your questions. They are designed for something else. For example, we are using Google Maps for navigations, and our data is being uploaded to the server. Then you can use this data for transportation. But it is not similar to the data that we have been used for example, surveying how people move in the city for transportation purposes. This is a fundamentally different ways. And that's a very crucial point, not to think about models. It's not anymore about models. This is beyond models. So this is the time that you think about local and temporal things, not models, which are like you're freezing a certain moment. And that's what happens in machine learning in principle. So with these data streams, I just want to go through it. It's not just about talking about it, and then I will show you, this is a kind of a framework that I'm working now. I'm trying to work on planetary level applications of urban, and you can't imagine that this is like it is a real-time, in principle, a picture of a real-time movement of all the satellites. So imagine these are all the commercial and non-commercial satellites, and they're collecting a lot of data, and there are lots of also, in addition to NASA, European Space Agency, and so on, there are also a lot of startups. They're collecting their own data. For example, there are recent startups. They have been collecting. They have sent their own satellites 36 satellites in 5 years, and now they have a daily picture of the planet. So think about it. If you are interested about urban dynamics, if you are interested about climate, if you are interested about catastrophic things, if you are thinking about climate change, now you have really this data. But think about it, that whether the courses that we learn in Bachelor of, I don't know, urban design or architecture are appropriate for that. So that's the gap which is happening now. So now you have these capacities, you can get this data. For example, you can get the data from NASA for, I think every week they had it for 40 years, every 2 weeks or every week. And this is a resolution of around 30 meters. So it's not really high resolution, but you have it for 40 years, almost the whole planet. So if you are interested to know how cities are evolving and so on, this could be a starting point, right? So, or if you think about other data sources, which are open source, maybe you're familiar with that. This is OpenStreetMap. This is a wiki-style project, like Wikipedia. They started in 2004, and now they have a kind of around 4 million contributors. And this is just a map to show you, for example, how many different contributors are changing the roads. And if you go to their website, you see that every second, in a way, the data is being updated. So that's the kind of, that was the idea of having an editable map of the planet, but now it's also an open source. So you can download the whole planet in your computer, and it's less than 1 terabyte. So think about it, what you can do with that. And think about it, like maybe 10 years ago, you were always thinking about, okay, I need Esri ArcGIS, and then I need to get the data from, I don't know, this company, Suis Topo, whatever. Now it's everywhere, everything is there. So that's beyond data modeling. It's just you need to know what you want to do. And then you can get this data. So now even think about it, if you're interested in, like, for example, curation of, I don't know, as an application, buildings. So you have around 300 million buildings indexed in this OpenStreetMap. So each of them, but you need to really parse them. You really need to learn how to, the whole OpenStreetMap is an XML file. So in a way, it's a kind of text file. If you know how to read an XML file, you have it. Like buildings, they have certain structures, and then you can render it like that. Not all of them, they have these renders of 3D, but then you have footprints and so on. And then, for example, you have types of who was the architect, when this building was built, what is the land use of that. So you can learn and then do a lot of data integration. Or you think about road segmentation, for example, or road segment. There are more than 100 million roads in this data set, freely available to use. And then, for example, I had once a meeting in German Aerospace Center in DLR, and then they are using their own satellite system to collect a lot of data. And this is a classical mindset, which is also helpful. But then they are trying to analyze these pictures to just get what are the footprints of the cities. But then the platform they're using to just show the map is OpenStreetMap. And then when you zoom in, the roads are already there. So there are lots of people using also machine learning to take these satellite pictures, detect the roads, and then upload it. So there are 4 million users, but I believe there should not be more than 10,000 users who are really nice. And I am not one of them, but I don't know why they are doing it. But you have these beautiful maps. So maybe a few years ago, it was not easy to get this detailed map from Addis Ababa in Ethiopia, but now you have it. So now the question is that what do you want to do? It's always like that. And then here also is a GPS traces of people. This is also crazy. If you go to their website, to OpenStreetMap, you see that these GPS traces are being uploaded every second. And so then if you want to use this for transportation purposes, this is a new data set. And again, if you go to DeBaug, and there are people working on, or any other university, if you go to traffic engineering people, they always start going to ask people about, I don't know, surveying. Okay, where do you live? Where do you work? How do you go there? And this is there already. So you don't need to ask that kind of questions, which are usually biased. If you know how to play with these different types of data stream, you can even validate it properly if somebody is saying differently. So this data is like, oops. Okay, maybe it's not good. forget. So I just want to show you that this is available. And also, this is my hometown, Tehran, and then I was not expecting to have that because usually if you go to Google Map, there is nothing about Iran. But then in OpenStreetMap, it was very cool because they had everything, and this is all the point of interest that you can imagine. So all the transportation location, all the banks locations, all the hospitals, the schools, everything. So there are more than 200 types of categories of items that you can think about. And I will show you what you can do with that, for example, in a second. So these are all the data that you can use. So from now on, I will focus on only four projects. I try to be quick. So that's, I think I already told you. So we have a kind of ecosystem of data providers, startups also working in this direction, also companies, also governments, a lot working in this field. A lot of other applications that you can imagine, for example, Facebook, Uber, Instagram, they also have their own APIs. So they have their own API, so you can get their data also. Google has, I would say, the largest data sets, but you really, it's not easy to get the data like OpenStreetMap. And then you can think about a lot of census data sets from different countries. And imagine in the USA only they spend 1 billion per year for the annual surveys. And this data is really amazing, but very expensive. So also recently there are some works that how you can use street view pictures and then predict what you can get from surveys. Because, for example, you can drive through the streets and then detect types of cars, and then you can guess which kind of income level they have. So then you can aggregate it. So there was like recent work, and they were showing that, yeah, maybe you really don't need to spend 1 billion because I think the most complete version is from the USA, but this will be every 5 years. Now imagine if you have these kind of things, and then Google, imagine every I don't know, every interval of time they are driving through, and then this could be other companies also, they can do it. Or if you have self-driving cars, they have cameras, and then when they're driving, they're already sensing, not just for driving, but for other things. And then if you're sharing this information, then this is a different world, right? So then they're also attached with the AI, so they can detect what's going on, right? So this is the setup, but then you should, and then what I'm trying, maybe it's too detailed, but what I'm trying to say that maybe if you go in this field, for example, go into this geoinformation modeling groups, they're still thinking to have a data model of cities, and then first you need to say, okay, what is a city, what are the elements, and so on, and then gradually build a data dictionary, and then try to push people to use this data dictionary in order to have a complete data set. Here, what I'm trying to show is that it's completely different. You just need to know how to use crawlers, how to get the data. If they are not API available, you really need to, I will show you how to crawl a website. So you can constantly get the data from a website. Or if they have APIs, how to use APIs. And if there are some data dumps or data collections, how to use this big data processing. So if you know these things, and then you should always start from the higher level, which is, as I said, what is the question? What you want to know? You want to predict what would be the effect of this coming, tsunami on cities. So you really need to go back and see which kind of data you have, and then you have expectations of the effect, and then you need to really build your own local and temporal data set, and then using this machine learning, then in principle you can predict what would be the risk. You really don't need to prepare everything forever. So that doesn't make sense anymore. So one of the interesting fields that I'm working and I really like is what if this data is available from different sources and they are all available more or less at a global level. Why not we should start thinking about urban at the level of planets? So there are also a lot of discussions, also here about different scales. Should we be local? Should we be really case-based? Should we be thinking about planetary urbanization and so on? But here also, this is almost in the same direction, but not necessarily the same methodological way. But can we just forget about these levels of I don't know, what is the border of a city? Who knows that? It's just arbitrary. What is the border of this neighborhood? What is this zip code and so on? What if we just have an index planet, and then depending on questions we have, we can define our segment. For example, if you're interested to know what is the possible air pollution in center of Zurich, it's not a problem if you, it's okay, it's even better if you know what is the air pollution level in everywhere else in the planet, because then you can learn, right? So then in principle, it's not against being local if you think about the whole planet, because you get the data now, it's available from the technological point of view, but you just need to know how to get it. So in this project, this is a very basic step. I'm just analyzing these basic hard factors. So for example, I'm just trying to calculate what is the urban density for the whole planet. Because there are also another trends of research called urban science, usually supported by people from complexity theory or physicists. They're interested to study cities, kind of the way they study particles, for example. And then they usually take some few data sets from somewhere, and then they try to generalize like urban scaling laws, and if you increase the size of the city, the energy consumption will be like that. And this is always a very I see that architects and designers which are really involved, they're getting really angry with that, because they say, no, it's not like that. And what is happening here, and what is my goal here, is that you don't need to generalize it to one single rule, but you have everything. You have the whole planet in your pocket, if you know how to use it. So then maybe that's the time to just forget about this kind of normative theories or this kind of models. I'm not against them, but I'm just saying that sometimes you don't need them. You just say, okay, I want to know why pollution is here. I can get some data set, I can test my results, and I can improve it. Or I want to know which cities are twin, for example, in this informational space. Twin cities are originally like cities which are close to each other, but you can find twin cities in this space, right? If I find cities which are having the same types of climatic regimes, for example, they have similar patterns of air pollution. So this is actually a good question, and people are looking for that, but nobody knows where to find it. So here, that's the idea. So I will show you quickly some of them that is, for example, working now like that. For example, you can get road networks, and instead of just always, you should think about it at the level of planet. You don't need to focus on one city, because then you end up to some local agencies and you need to ask them, can I get your data? They say no. But here, just think about it, the whole planet. I can't run it on this computer, but it's up there, but I couldn't also connect to my computer, so I will just show you a small scale. For example, this is if you get data from OpenStreetMap. Maybe I should show you where is this OpenStreetMap data coming from. So you really need to go there. I will come to this later. For example, you really need to, where is that? Okay. So you just really need to go OSM planets. And then, for example, yeah, this is the good one. So, for example, latest weekly planet XML file is 70 gigabyte zipped. If you unzip it, it's more than almost 1 terabyte. This is updated 4 days ago. So if you get there, everything that you see on the OSM map is there. It's like you download the Google map. It's not that as good as Google map, but it's 80% good, which is enough. So then think about it, that you are not searching Google Map, you are downloading Google Map in your computer, and that's what I'm interested in. So then you can say, okay, I'm interested in roads, for example. So there are lots of nice libraries. For example, this one, OSM2PO. They convert these road networks, which is an XML file, to a graph. So I have the graph of the whole planet road network. So if you're interested in the graphical analysis, just do it at the level of planet. It is possible now. And then, for example, it's not possible here because it's too old. But here, imagine now I'm uploading now as a data set, I'm uploading 6 million road segments. This is only for Germany, Switzerland, and Netherlands. So this is the data you get. OSM ID is unique. You get like a OSM target ID class, which tells you which kind of roads is that. And then even you have then you have the source, you have the targets, which row, and then it tells you that the connectivity or the direction of the road, and then it tells you the length of the road, it tells you the speed of the speed limit of the road, and then cost and reverse cost and so on. And then you have the locations. So then there's also again another technical question, how to visualize these 6 million points or 100 million points. It's not easy, but there are also again open source community helping a lot. So for example, this is what you can get. And then for example, this is Switzerland, and you see, so you see it goes to the level of details. And then, for example, if you're interested to calculate density, if you're interested to know what are the types of roads, distribution of different types of road and so on, it's possible. And this might make a lot of people in this field of urban science very happy, because this follows this so-called power law distribution. This is the road length. So there are a lot of people publish paper in Nature or Science, and they say if you observe these networks of road networks, they follow certain probabilistic distribution. And in this case, you can say yes, it's true. And this, you see that majority of them are very short, and then very, very few of them are very long. This is in principle, this idea of power law distribution. So now what I can do is that I can just play with that. So also I can now make queries of that. I can slice them. I can say, just show me those roads that have a speed limits of certain amounts. I wish I could show you for the whole planet, because then there are some crazy patterns, I don't know why. But then, for example, you see, if you go 1, this means that speed limit is from 10 to 150. So I just show you the roads which have like the speed limits of 20. And then when I increase it, you see the majority are here. And then you see then different spatial patterns are emerging, which I don't know if there's, it should not be random, but nobody knows. And also you see that after certain, you see that the way that they're calculating these speed limits, and also the way their regulations are being set are different. This is for the Netherlands here. You see it's different pattern. And then you see they're completely different patterns. And then you see after a while you have the whole networks, and also you see again different things. I wish I could show you this kind of analytics, but it's not possible. I have this kind of analysis. For example, now you have the road networks. Now you can calculate the density of the road networks like this, and this is zoomable. For example, now you can add any other layers. There's the vector data, and then for example, just again similarly for fun, to be honest, you can think about buildings. So a lot of people working on this field of urban morphology, you want to calculate how dense are the cities. So you have the buildings footprints, and now I have them for more than 300 million buildings. So I go one by one, open them, convert them to a polygon, calculate the number of corners, and then I just save this data. So in principle, I can create a map of cornerness of so if there are some interest. So just give you a background, this is, I mean, I don't know how much you are in this field, but there are some people working on this are super happy to find universal patterns here. And the whole idea of this project is that, what if we just do it for once, not sampling, just saying once forever, this is the number of corners of the building. Then what? That's the whole idea. So not to push it too much to create a science out of that, because there should be some patterns. For example, you can go to Europe, definitely the topology of the building should be different than if you go to other part of the world, because of the age and so on and so on. But I don't know if it in itself is a science. So for example, you see that this is also buildings. So this is the density of the building. Also, I couldn't show you, but then there is another map to show you how building topologies are different in the whole planet. So it's not always to just map it for the whole planet, but sometimes you can ask questions. Now this is the next application. So for example, also you can think about urban centers. So instead of focusing on few famous cities, this project that I'm going to show you is that, what if we just look at the urban form or road networks in 1 million cities? So definitely you can't do it manually. But can we use machine learning to curate this kind of data set? So now, the challenge was that this is the second, for example, application, but also connected to the first one, is that we either have very conceptual urban forms. For example, what Lynch was doing was very amazing in his time, like these tripartite models you have. Different people are working on that, and they're trying to come up with new things. Also, this correlates with these levels of abstraction in computations. For example, you can think about City of God, or for example, Lynch, and then you have City as a machine when you have this kind of computational mainframes, and then you have City of ecological cities, which is the time of exactly internet, network, sustainability, or they're all correlating. Also, you can think about these tripartite models of Cedric Price, for example, this kind of analogies to boiled eggs and then scrambled eggs and so on and so on. These are very interesting, but also just conceptual. And then if they're quantitative, they're based on limited observations. So I have friends, good friends, that they're like really focusing on the networks of 10 cities and then try to come up with some universal patterns. So this idea again was to be a bit aggressive, to just say, what if we just do it for the whole planet? So these are each points, and in each point now, instead of just calculating, I go one by one. I hope it's running. And then to take photos. So also you need to know, for example, how to style these maps. I hope it works. So imagine now I'm going to each of these points, and then I create a styled map which shows me only roads in red color, buildings in blue, and greens in green. Oh, sorry, parks in green, or greenery in green. So you have RGB channels in the picture, right? So now each frame is one city or one location. So now out of this, is it possible to find some similarities? So I'm interested to know, this is my city, is there any similar city like this network? So now if you use, I believe last week you talked about this deep convolutional neural networks, so, or maybe later, if you think about these deep autoencoders, now you can think about it and then train this kind of models. And then I hope there's a link here. And then you see that it creates this kind of patterns of different cities. Maybe you have seen the poster over there. I'm just wondering if there's a link. So that's a model here, and then this is a kind of, now you can this is what I told you about this Google-like search, but the whole planet. So you say, is there any similar city pattern like this? So the answer is like that. So you can't do it without this advanced machine learning, because you have 1 million pictures, and then I want to say, is there any similar pictures to this picture? So you literally need to use this machine learning there. Or you can say this one and it gives you this one. Or if you say this one, gives you. Or also you see it learns in principle forms. And think about it in an abstract way, that this could be any question. This is just form, but this is the interesting part with machine learning and data. It could be, okay, I have 1 million cities, 1 million measurements for something, modes of transportation. Can you find similar cities, or can you find similar patterns? You know, then this machine learning is not going to learn something about roads. It's just learning to associate your inputs to what you're asking. So here is just learning similarity of the forms, but it could be learning road networks with modes of transportation, or how many people would drive in this city, how many would take the, for example, public transport. And then you can, of course, you can create this kind of curations. So, for example, it tells you that these are the clusters of the cities, and then like these are more dense cities, and so on, right? So in the second part, I will show you again two applications, almost the same story, but now with business. So some of them, it makes sense to just publish papers, but some of them you should maybe test it in the market. So because of that, I'm almost half time of the year I'm really pushing these things with the companies, and sometimes I'm also writing papers. So for example, now think about it, that now I told you about these kind of questions. Can we find similar, for example, development projects? This is really a question. You are in an early stage of a project, you have a plot of land, and then you say, what should I do here? So you have experts, usually they come and say, okay, we know what is good here because we look at the trends, we look at the neighborhood, and so on, and so on, and so on. But then here we just want to test this. Is it possible that having a location, this is especially behind Prime Tower, having this location, can you find similar projects in the world? So it's funny, huh? Because it's again the same kind of thinking, but now you really need to think about different types of data. So here we just look at the point of interest, and then for each location, for example, in this case, because it's just North America and Asia and Europe, it's just around 20 million locations. And then you go one by one to this location, and then you say, like, point of interest means that, I can show you, different types of activities in the city. For example, bus station is a point of interest. A cafe is a point of interest. A restaurant is a point of interest. But also you have the names, right? So, for example, again, just to show you that it's simple, it's here. And so, for example, if you go to Zurich, this is again OpenStreetMap. So you just show me all these types of businesses. And it loads all of them for you, but now you need to download it. So what is happening here is that you download these, all of them, and then each of them, if it's a bus station, you look at this bus station and think about it like the concept of Facebook. In Facebook, they say if you have liked 300 items, it's not necessary to know who you are, but we can predict what you would like. So think about it for this real estate project. Is it possible to think about like that in a very early stage, just for brainstorming? Now I look at each of these points and then create a radius of 300 meters, 500 meters, 800 meters. And in every time I do that, I just say how many of each of these categories exists. It's like how many of them these guys liking. You have 180, 170 categories, and then you say, this bus station, what is this bus station liking around? And then you do it for different types at radii, and so you have different 300 meters, 500 meters, and so on and so on. So you vectorize these points in a self-referential way. So I assume that there should be a reason why there are a lot of theaters, for example, in this area of the Zurich, if I don't know it. But I assume that there has been some logic and some ideas behind, but I don't want to know them. I just want to assume that there are some patterns. So I vectorize them by what is happening in their neighborhood, and then in principle now I have, for example, 20 million points. If it's, for example, almost a whole planet. And then in these 20 million points, I have a vector of 180. So now you have a new site, and then you say, what should I do here? I don't know. And it's like a void. So then you say, find me similar twin areas. Is it working or not? You can't ask this question at the moment in Google, but in principle, when you're searching in YouTube, they are doing for you because they have indexed all the videos to a vector of, for example, 256 dimensions. And then when you're searching, if it's not based on keywords, it's based on, for example, comments, they are just searching in this 256 dimensional vector band, because of that it's super fast. So now I'm vectorizing the whole planet for my question. And then if my question gives me some result, I will go to another types of data set. So you really need to collect the data from here. And then again, as I showed you, download it, filter it. I can give you these codes also. So you need to really detect, for example, show me only highways, or show me only different types of point of interest. And this is again just for Switzerland, but again in my computer upstairs I have it for the other areas. So each point you have location ID, unique ID, and then you have name, and then you have type. So then you say which types of categories I have. It says in Switzerland the most common point of interest is bus stop, is next restaurant, and then is hamlets, and then peaks are very important in Switzerland also, mountain peaks, and then education, school, and so on, right? So then you can visualize it like this, and also you can visualize it like that, layer by layer, for example. Show, for example, if you say transportation bus stops, I hope my computer is not working properly. So it gives you a heat map of bus stops. And for example, now this is the layers of data that you're going to vectorize. And for example, I don't know if anybody's from Switzerland or you're. So for example, this for me was interesting in itself, because if you visualize the hamlets, it shows a clear spatial pattern around Zurich. You see the density here is much higher. I don't know why it's like that historically. Anyway. And then, for example, you have all of them, right? You have like 160 layer like that. You can play forever, but here we just want to think about them as like items in Facebooks that these guys are some of them, right? So you create a vector, and then here, this is small short code. You just say for example, in 600 meter, for each of these categories, for each point, say how many of them exist, and then you have this now. From the previous data set, now you have this. Bus stop, 16. Restaurant, 10. And then the others are like some numbers. So now I have my own location. And also, for example, if you're interested, you can cluster these areas. For example, now, if I calculate all of them, and then cluster them based on their similarity, it gives me something like that, which is not really beautiful, but you see that it finds that there are some spatial clusters of the activities in cities, right? So this is very central, and then Oerlikon also, you see that it has its own kind of new centers. You see then for example, colors are based on similarities, and then for example, I don't know, if you go to this area, there should be also some kind of centers, but you see the center, the clusters are not the same as Zurich. But then this is just intermediate layers. But then you can say, okay, I have this site, for example, this is a building, it's called Bau Arena, maybe you know, in Vogelsville. So I want to say if there is similar buildings to Bau Arena. This is just for Switzerland. And then I do these kind of things. I don't run it because it takes time. And then it tells me like, look, out of these, in this case, 150,000 locations, these are the locations which are very similar. And then since these points which are close to each other, they share the same data set, you expect that you create kind of clusters of points. So first of all, I think this is the case itself. So this is the site itself. So it says it's similar to itself, which is obvious. And then, for example, then it finds other neighbors. So, for example, it says, for example, maybe you should, if you don't know this area, for example, it tells you this is an area for selling, I think, building materials and decorations and so on. It's called Bau Arena in Vogelsville. And then you have these kind of pictures. And then now you get these kind of clusters, and it says these are similar. And that what was the case here. It was not for development, it was for finding tenants for commercial buildings. So because you find similar buildings, then you say, which brand is missing in my building? Can I call them? Because you really don't know what would be a good tenant for this kind of mixed-use commercial building. So for example, it tells you that this might be interesting. There's another area, and then it says these companies are there, mobile, and this one, MediaMarkt. Again, this is Bau Arena itself, sorry, I made a mistake. So this was something else, this was the Bau Arena. So then it says, for example, this might be interesting, and then for example, there are different brands that I really don't know, and nobody knows all of them, that's interesting. But you know all the names now. And now, if for example, for this case, they wanted to know what would be the potential tenants for this building. So now we can give them a list of 50 potential companies which are appearing everywhere, but they don't exist in your building, right? So this could be a use case. But then for the case of developments, I almost did the same thing, but for the whole planet. And the result also was interesting. I personally don't go to the details because then it's disturbing. So this is a data set for another location, which is a very, very early stage of development. And this is just very wild kind of test. So for example, if you look at 300 meters, this is a site in Switzerland, and then it finds all of these sites all over the world. So that's very cool because you can be confident even if you know that it's not correct, because nobody knows all of them, right? So now, for example, what we spend time on that, I have a partner, and then he spent time on that going one-to-one, for example, to these sites, for example. Then it says, okay, somewhere in Toronto or Montreal, for example, this might be interesting for you because the setup and the combination of the land use and so on, it's similar. And then, for example, you can click and then go there, and this is for nowhere, in no way this is the final answer. This is just for creating ideas for you. And then you have these kind of things, and then you can imagine create these kind of 3D views. And now, if you really want to go further, out of these 2,000 locations, which are clusters of, let's say, 200 areas, you can really take Google Street View API and then really analyze it from different angles, create 3D models and so on. But more than that, what is interesting for this site, for example, which similarly says this is similar to the area close to Prime Tower. I don't know, is it similar or not? I don't validate it now. But then what is interesting is that if you find who is the constructor of these companies, because also you can do it for buildings which are under construction. So you go to tag info, for example, in here, and then you just say construction, and then it tells you that, for example, there are more than 300,000 buildings which are under construction, or you can say buildings which are under construction. So then instead of looking at 20 million, you look at 300,000. This was also the case. And what was very interesting is that out of them is not, if you think about it like a workshop, if you have 10 groups, it's very easy to do all of them because there are not many sites. But what was interesting is that you can find for these new buildings who is the construction company, and then they always have a nice website, and then you see what are the other projects they are doing. So then you see it's like creating a lot of interesting vibes. Otherwise, you are in a company, you say, okay, I know what is good for this building. Everybody likes co-working space. Let's build co-working space is a cool topic now, right? So now we just say, maybe I found something which is not there yet, and we don't know. For example, if you go, for example, maybe to Japan, if there is any similarity at all, or don't know. But for example, maybe there might be something. So it's really funny that it finds these kind of things. Also, it finds distances to, for example, density distances to the train stations, whatever. And it's just based on this point of interest. And imagine now we can go much more in detail. So you say, okay, now take photos of these potentially similar buildings, and then again use machine learning to find if there is some similarity in their facade, for example. I'm interested in, I don't know, green facade. In Singapore, everybody likes it, right? So can we find and justify this by data? So you see, this is another building. The data quality is not the same, but you can start thinking about it and elaborate a lot around it. So this is also kind of questions that I like to call it, is it possible to have a kind of Google-like search engine for a spatial search? Because Google, the beautiful thing with Google is that it's not in a way trying to generalize everything. It just gives you some result and you say, I like it or don't like it. But it's not telling you that based on this theory, this is the best answer. So it's just evolving. And if you don't click on that, it's not getting better. But then for these kind of questions, you can't directly ask in Google because you need to really get the whole planet data. And then depending on your questions, you need to focus on certain aspects of Google, for example, Google-like map. So this is the direction I'm moving. So this could be on different applications. This could be, I don't know, street view pictures, and then again search, point of interest, other data set, and so on. So I will show you the last one, which is a case I've been working almost for on and off for 2 years, and yeah, until 1 month ago I was really close to start my own company, but then we didn't have an agreement with the investor, so I'm here again. But this is the idea of real estate, and this is a story when it was like 3 years ago, and the idea was that, okay, if you have if you know machine learning, can we predict rental price or evaluate housing? And then I immediately started talking to known companies in Switzerland that I think you know also, like Houston Partner, these are like Farlanders and big companies that are really selling their expert-based consulting, which is very expensive. And then I just realized that it doesn't work like that, because first they are already plugged to these banking systems and so on. And it doesn't matter, is it machine learning or old school method or expert-based, whatever, it's just working, it's business. It's not about really improving it, it's about how to make it lock in. So then in principle I started crawling. That's the new types of data collection. So far I just show you how to get APIs and this kind of data set, but you can also crawl a website, and this is the cool part. I would say this is the best types of data collection. So for example, if you go to HomeGate and then you go to this area and then you say, okay, I want to rent a place in Zurich. So it tells you this, right? So you get this result. But you know, you can, you can get the data behind also, right? So when you're downloading, this is data on your side. So if I say inspect, you see the data is that the website has a structure. So in principle, you can get the data all one by one. So that's not a problem. So you can write what is called a crawler or scraper, and also you can outsource it if you know how to do it to another guy, and then in principle mimic your behavior that I did here for everywhere in Switzerland, right? So I did this, and this has been running for a few years now. So look, this is the data set I am getting from HomeGate. So I go line by line, and then I get the data, and then it's like I'm clicking on that. And then again, I even can take pictures, I can take the address, and then geocode the address. I get all of these features, and then on top of that, I can train my machine learning models. So I'm doing this, and it's part of the ecosystems. For example, if HomeGate says they have 2 million unique viewers per month, 50% are this kind of crawlers everywhere for every website in the world, which are famous. You know, if my website nobody crawls because nobody cares. Number of views like 100, 20 per day. So here they say we have 1 million or 2 million. So believe me, it's like half of it is like me. I'm sending 40,000 requests to them. So it's like I'm searching everywhere. And then you can also add other data set. In Germany is 8 times bigger. In Netherlands is the same, almost the same. And then also this one is Auto Scout. So you can also go out of these fields of urban planning. You can go to other topics which are not spatial. These are cars you can get. This is for example Twitter for certain hashtags. This is for example air pollution from 8,000 locations. So these are like they become simple. You can just add them, and also you can outsource. If you know how to do it, then you really can outsource it, because it will cost 100 Swiss francs, one website, 1 week. So think about it, how many weeks you have and how much money you have, you can do it. And all of these job portals are doing that. You know, is the way is called aggregation. So what we want to do is not aggregation. We are just interested to use this data to, for example, predict. So I use this data set in the beginning, and then I just realized that, wow, it's easy to predict, because now I can use this data. Also, I'm using other data sets from other sources, so I can create this website, and then in principle, you're welcome to go there and then just check the price of your house. This is just for rent implemented online. And then this is more than 94% accurate in terms of median accuracy. So it's working. And then I just realized that even this is not sellable. So we went one step further, and now you have these kind of things. So for example, you have these types of information. You should buy this in principle, but if you put it properly, now the whole idea is that can we make it for free? Because what I believe is that if I make analytics for free for people, and if you get traffic in a way, then the actions of viewers is a new data set for you. Because then you know willingness to pay, who is searching where, and you know which kind of interest you have. For example, HomeGate in principle throws away this data set, but you can create and then keep this data and say, what is the duration of an ad in different zip codes or every point? So then you can create a kind of dynamics in that real estate. So which areas are more competitive, which are areas like super dead. So you can add a lot of them. Also you can use data set from, again, OpenStreetMap. This is the building prices estimation of price per square meter of all of these buildings. So you can also do that. And then on top of that also you can do this kind of things. And when I'm just talking about this, I'm not trying to show it off, but I believe that this was my first, for example, web application. But if you're really thinking like that, you can really build it independent of the questions or domains. So that should be, I would say, the way, if you are urban planners, you should think about planning. Learn and being skillful and learn how to use data and then represent it in a different way. And we should not think about anymore like Excel files or, I don't know, Esri or this kind of things. So then on top of that, I can create this kind of analysis. For example, this is the asking price. I can say this should be the good price. So in principle, it's not a good deal for you. And then I can also calculate number of rooms by average and a lot of this kind of stuff. And even this doesn't sell. If you have some ideas, you're welcome. I'm looking for co-founders. But then we went one step further, because now the idea is that this is all about the objects, but how about you? If you look at HomeGate, if you go to HomeGate, you go to Zurich, you say, I like this and I want to have at least 2 rooms, I can't pay more than this, and then like that. So every time it shows you the same result, because they're a click-based company. They want you click and they get paid from the advertisers. So they don't care if you like it or not, but the only way that you can find the listing is, for example, HomeGate, right? So then in principle, the interface is designed for a generic user. So the whole idea now is like that can we have a dating platform for real estate that, for example, we would like, and this is what is now we are developing, is creating a personalized HomeGate for everyone, because it's possible with machine learning. So imagine now I'm crawling for you as a person, if you're a user, I'm crawling everything, but then you should tell me which one you like, which one you didn't like. And then I go and I learn which kind of patterns you would like. This is not technically possible for HomeGate, because in principle there is just one window and then you just go and look at it. But now with this kind of mobile apps, you can make it personalized. So this will be like your personalized assistant, and then dating is like, in addition, instead of talking about renting, this is dating, because dating is a lot of quality and you should really show off, you should really be everything. And then this is a lot of factors around that is not in HomeGate, and now we have it with this big data. So, and also it could be in terms of interface, could be similar to other dating platforms. And then think about it now that these are the few features like those, like this one or this one. These are the data you can get from HomeGate, but we can calculate the prices. So I can give you a lot of data about if this is a good house, what is the neighborhood price, what is the existing, what are the rents of your neighbors, existing neighbors, and so on. What is the street mood? What I showed you in the previous case. Now imagine, I told you, like I showed you this road networks and then similar road networks. But now think about it. We have 100% coverage in Switzerland. We take data from Google, a street view, and then drive, and then find the locations of advertisements. Look around, 3 pictures. So every site, every house, you have 3 pictures. Go. And then first of all, you can create this kind of street mood, because when you look at the streets, you can find similar neighborhood, for example, right? So first of all, you can create this kind of search based on street mood. For example, if I tell you that this is a good house, but you say I don't like the neighborhood, how do you want to tell to HomeGate that I don't like these types of neighborhoods, but just based on the look? And now with this deep learning or this kind of machine learning, you can do it. And going one step further, also you can train these models to look at these pictures and tell you what is the price. And also they can detect types of car. And this is technically possible. Maybe 10 years ago it was not possible, but now it's possible. And also you can look at a lot of things. You can curate maps, for example, say this area is like full of this kind of types. This is a heap area, this is rich area, this is university part. You know, you can create this like this. And then you can create, and that's the whole idea of this startup, to create this matchmaker engine that from the other side also we are going to ask you, where do you work? If I know where you work, then in principle looking at the data from SBB, which is for free, and Google is using that for the transportation, you can also get it, the whole data from SBB. You can pre-calculate the commute time from any point to any point. So if you tell me we are a couple and we live in this, we work in this and this, so we are looking for intersections, right? And then we are using public transport. So this could be also a new way to search. And then also if you tell me if you have a car, and if you tell me which types of car you have, in principle, this private and personalized, it should be private, it's important. It's not another Google necessary, because also Google is not able to do it unless it's private because of the technicalities. So with these kind of questions, also you can think about it that this is another applications, but I try to tell you that the core logic or the core story is the same. It's about your questions. In this case, we thought that dating is a good idea, and also information overload is a problem now we have. In HomeGate is information overload. For example, you don't know where to look. It's a lot of advertisement. And then we say information overload, and then click-based companies. How we can change this? So that was the idea of dating. In the previous case was for getting ideas. Where can I get new ideas for my projects? So that was like, then you really think about which kind of data I can get. So based on that, you will search. And then, and the same, so, right? So I have other applications, but it will be a bit boring and I think too long, but then there are different fields. But that was, for me, the whole message, that now with this big data, you have really a beautiful freedom. And of course, with Google, if everything is for Google, and then they're telling you what is good for you, that's not cool. But now what is interesting for me is that I believe with these computing technologies and also the availability of these open sources, everybody should have one Google at home. That's the whole idea. So if you have the whole planet and you're sharing your planets with the others, that's really fun. Because then you can find friends, you have privacy, and it's not just always telling you what is good for you. Then you can think about it like like your own personalized system. And then if you are into university, you should find applied questions for publications. If you're industry, it's different story, right? So yeah, that was it, I think. So if you have questions now. Yeah, you can ask any question if you like. If you don't like some part, or yeah.
Is it always easy to access this information, or because there is the OpenStreetMap, but is there sometimes difficulty to access some other information, or do you have to pay sometimes, or is it?
Yeah, that's possible. Yeah, it's like this is the first step. First, you need to know, okay, there is a big data. I want to use it. I can't use it. That's the first thing. But the second question is, okay, which kind of data you want to get? So for some of these applications, you need to pay, but for some of them, it's usually for free. Everything from OpenStreetMap is for free. You can download it, but the price is that you should really learn how to handle that. And this, I promise you, if you, and also there's again wrong way to think about, okay, I want to be master of OpenStreetMap. That's not correct. So you should just say, what is the questions you have? For example, this is a research question I have, and I assume or I can guess that I can use some sort of data. So then be really careful what are you going to use, and then learn the difficulties or easiness of these sources. For example, OpenStreetMap, it's super simple, but the risk is that maybe there are some errors in the code, because there are a lot of people who are really validating that, but in principle it's possible. But that's like a daily activity, you know. That should not be a problem. Just you should make yourself familiar, and then that's a way I would say you can also learn a new language. You know, it's like, of course you need to learn a bit of grammar, structure, and increase your vocabulary. And this is for me the way I'm thinking about machine learning. You need to learn, and then after a while you just realize that, okay, I know all of these data sources. I can guess how this guy is visualizing this. It's super simple. And then the beautiful thing is that in computer science community, everything at the moment, I don't know what happens in the future, everything is open source. And because of that, it's faster than the others. For example, if you go to pharmaceuticals, if you go to medical, everything is closed. So you really don't know what's going on in Novartis. But you almost know, not, I wouldn't say 100%, you know what's going on in Google or Facebook. And that's a different setup, because it's about information, and then if you share information, it gets more, unlike the other limited resources. Because of that, the ecosystem is super open. And imagine now, for example, recently NASA just accepted that, I don't know, all of their data should be in principle freely available. Now the question is that who wants to use these 40 years of the data, right? Because it's huge. And they build a lot of nice interfaces for you to search, find your data set and so on. But you just need to go through it, and then it's a step by step. You learn how to get the data. And APIs are the standard of the software development nowadays, because even nobody's, in principle, not everyone, but in principle it's possible that you don't develop your own website anymore as a centralized server. And now this is a kind of hot topic to have microservices, for example. You can have your database somewhere, and that server, small server, is collecting data from other sources of the data, cleaning, and then put it somewhere in a static database. So you just need to know how to talk, and then they're talking to each other. And now my implicit idea here was also that cities, buildings, regions, they also are able to talk to each other. You really don't need to have a kind of abstract and generic model. So if you get this, and if you like this idea, then the rest is just craftsmanships and technical day-by-day activities to get the data and so on. Yep.
Okay, happy or
I think they're happy as long. No, if you directly tell them that you're doing that, I told them, I had a meeting with them, but this is part of the ecosystem, you know, because, for example, you know Comparis? This website of Comparis, they are crawling everything. They are called aggregator. But then the business model is that after a certain level of having traffic, they go to HomeGate and say, look, we are re-advertising your advertisement, but we don't get paid from the advertisers. But if we send a lead through our website to your website, you should pay us, because we have also 2 million unique viewers. And then HomeGate is super happy. And then Comparis is super in a very risky situation, because Google doesn't like Comparis. Because Google says, I am the aggregator. I want to have direct access to the sources, not the Comparis. But then Comparis plays a lot with this so-called SEO or SEM, this how to go up in Google. And then after that, you go up in Google search, and then if people come to you, then go to Comparis, and then through Comparis go to HomeGate are happy. But then what I am doing directly, if one day I come and say, okay, you just come to my website, advertise for free, that's not cool. Because I should do it, and they can't do it, because like this case I showed you, the problem is that, imagine I pay 100 Swiss francs to HomeGate to advertise my house, and I expect that you are equal to every advertisement, so it should be in the listing. But then the user comes and opens the website, and it says the asking price is 4,600 and the market price is 4,300. So your price is not good. So then they get pissed in principle, right? Because they say, we are paying you, just advertise. You're not supposed to analyze. So if you think about analysis or analytics company, these are the second generation that is started from 2008 almost. HomeGate is 2002, and so afterwards. So super stable, and they are not, they're very rigid also. Yeah, just, I don't know, because we are recording, but I'm just thinking, they have around 90,000 advertisements per month. Each is like 100 Swiss francs. So the cash flow is like 9 million per month, and it's just 50 people. So they don't touch anything, and it's just working properly, and they're locked to these advertisers. And now what we would like to do is to say, okay, but HomeGate creates information overload. The same way I would say Instagram is creating information overload by this Explorer, because they just want to increase the so-called screen time. So if they increase the screen time, they get paid more. So now the whole idea of this dating platform is that what if you have a HomeGate for yourself at your home, and also you can put it in a box running in a home server. So then we are attacking this problem of information overload, and the idea is that can we make it simpler for people, because people should not click, machines should click. So then in that sense, if this works, the demand for HomeGate will be lower. Then they're not happy. But if you're polite to their server, and if you know how to rotate your IP, they can't catch you, and they know it. They have like 40% this kind of crawlers for all of the websites, almost. All the websites which have like directly to the B2C models, like Zalando. If you go to their server, they have crawlers forever, for sure. And if you go, I don't know, any company, eBay and so on. Yeah. Okay. So that was the end of it, huh? Or you want to ask some questions you said? I don't know. Is it okay? Okay. So, thank you. Thank you.